Hello everyone, a very good evening to all. I once again welcome you to the interaction session on atomic and molecular physics with course code NOC 24PH04, which is being flowed this January 2024 session. Today is our 10th interaction session. In the last interaction session, we had covered a few problems which were based on the week 9 lectures that covered the rotational and basically molecular spectra. We have started solving problems related to the rotational spectra of molecules. So today also we will continue our discussions and we will do a few more problems which will be based on the rotational and again vibrational spectra. So let's start with the first problem of the day. Now the question says the moment of inertia of HCl molecule is 2.7 into 10 to the power minus 47 kg into meter square. Estimate the energy difference between the lowest rotational state, which corresponds to J equals to 1, and the ground rotational state, which corresponds to J is equal to 0 of the HCl molecule. And it is given in the question that we will take the value of the Planck's constant H equals to 6.626 into 10 to the power minus 34 joule into second. So I'll give you a few minutes, but before that, let's understand the question in a better way. So here it is given the moment of inertia of HCl molecule. So since we are talking about the moment of inertia, so moment of inertia comes into play when there is rotation of the molecule. So this question is based on the rotational spectra of hydrochloride, hydrochloric acid molecule or HCl molecule. And here the moment of inertia is given. And we know if we know the moment of inertia, then corresponding to each J value, we have different rotational energy levels and the energy values also we know according to the formulas that are based on. And using those formulas, we will calculate the energy difference between the two levels. What are those levels? One is the lowest rotational level, which is J equals to 1. And the second one is the ground rotational state, which is J equal to 0. And since we need in calculation, we definitely need the Planck's constant, and the value of the Planck's constant is also given. And the options are 8.23 into 10 to the power minus 3 electron volt. Option B 6.25 into 10 to the power 3 electron volt. C 4.62 into 10 to the power minus 3 electron volt, and 2.57 into 10 to the power minus 3 electron volt. So these are the four options. I will give you a few minutes to try this question, then I will solve it. So let's solve this question now. For us, it is given that the moment of inertia, which is represented by I for HCl molecule, is 2.7 into 10 to the power minus 47 kg. So the moment of inertia is given, and we need to estimate the energy difference. So what is the expression for rotational energy of a molecule? So we know the rotational energy of a molecule is given by Ej, where J is the rotational quantum number. Ej is given by h cross square divided by 2I j into j plus 1. So the energy corresponding to J level depends upon the value of J and J plus 1, where J stands for 0, 1, 2, 3, and it goes up to higher value. So here in the question it is given that estimate the energy difference between the lowest rotational state and ground rotational state. So we need to find out E0 and E1. Now E0 corresponds to J equals to 0 and E1 corresponds to J equals to 1. This J equal to 0 is called as ground rotational level. Ground rotational level, and J1 is called as lowest rotational level. And this is the expression for energy of the rotational level having value J. So for J equals to 0, we have E0 equals to h cross square divided by 2I, 0 into 0 plus 1, which will be 0 only. Again, for J equals to 1, E1 will be h cross square divided by 2I, 1 into 1 plus 1, it will be h cross square divided by 2I into 2. So it will be 2h cross square divided by 2I of h cross square divided by 2I. We know h cross is nothing but h by 2 pi. So this energy E1 can be given as h square divided by, so now this 2 will get cancelled out, so there will be no 2 here. So this 2 will get cancelled out. So h by 4 pi square I. So now see the values of I is given and h is also known to us. So now if you see, the energy difference is nothing but E1 minus E0. So energy difference delta E is equals to E1 minus E0 is h square divided by 4 pi square I minus 0, because 0, the ground state level is 0, which corresponds to J equals to 0. So it will be only h. So delta E will be nothing but h square divided by 4 pi square I. We know the value of h, which is given in the question. It is 6.62 into 10 to the power minus 34 square divided by 4 into 3.142 square into I. The value of I is also given, which is 2.7 into 10 to the power minus 47 kg. 2.7 into 10 to the power minus 47. So if you calculate it, it will give you around 4.12 into 10 to the power minus 27 joule. Why the unit is joule? Because here you see all the units we have taken are in SI units, because H is taken in joule into second and the moment of inertia is taken in units of kg into meter square. So the energy will be coming in terms of joule only. But in the options, if you see, all the options are given in terms of electron volt, and we know 1 electron volt is 1.6 into 10 to the power minus 19 joule. If you convert it, yeah, we have to, in order to convert joule to electron volt, we'll be dividing with 1.6 into 10 to the power minus 19. So I think this is not 27, this is 22. So if we divide 4.12 into 10 to the power minus 27 divided by 1.6 into 10 to the power minus 19, it will give you 2.57 into 10 to the power minus 3 electron volt. So this is the correct answer, 2.57 into 10 to the power minus 3 electron volt. So if you see the options, the option D will be correct, 2.57 into 10 to the power minus 3 electron volt. So the question was, the moment of inertia of HCl molecule is given and it was 2.7 into 10 to the power minus 47 kg into meter square. And we had to estimate the energy difference between the two levels. What are those? Those levels were rotational level, lowest rotational level, which corresponds to J equals to 1, and the ground rotational state, which corresponds to J equal to 0. So we know the expression for rotational energy of a level having quantum number J is given by it's h cross square divided by 2I J into J plus 1, where J, the value of J varies from 0 to higher value, with 0, 1, 2, 3 like that. And the I is here, and the I is moment of inertia, which is also given, and the moment of inertia for HCl molecule is 2.7 into 10 to the power minus 47 kg. So if you put the values of J equal to 0 and J equal to 1, you will easily get the values of the two levels. And since the value of J equal to 0 level is 0 only, so the difference in energy is nothing but the value of J equal to 1 level. So the J equal to 1 level, the value is given by U1 equal to h cross square divided by 4 pi square I. So the difference in energy will be equals to U1, that is h cross h square divided by 4 pi square I, where h cross is h by 2 pi. So if you put the values, since all the values are known to us, so when you put the values, you will get the answer. The answer is 2.57 into 10 to the power minus 3 electron volt. Remember that when you are putting all the values, since all the units are taken in SI system of units, so the energy or the difference in energy, whatever it may be, it will be coming in terms of joule. But since options are given in terms of electron volt, you need to convert joule into electron volt, and the conversion factor, if you are converting joule to electron volt, we will divide 1.6 into 10 to the power minus 19, which is nothing but the charge of the electron. So if you divide it with the energy value in joule, it will give us the electron volt unit of energy. So the correct option will be option D in this case, which is 2.57 into 10 to the minus 3 electron volt. I hope this is clear to all of you. Then we will proceed to ask the next question. The question says, the bond length of carbon monoxide molecule is 1.13 angstrom. Find the energy difference between the lowest rotational state and ground rotational state of the molecule. The options are three. Also, during the calculation, we will be needing the following values. the values of H is given, which is again 6.62 into 10 to the power minus 34 joule into second, and the reduced mass of carbon monoxide is given, which is 1.14 into 10 to the power minus 26 kg. And the options are option A 4.77 into 10 to the power minus 4 electron volt, 3.77 into 10 to the power minus 4 electron volt, 2.77 and 1.77. So these are the four options. So if you see the question is pretty much similar to the previous one, but in the previous one, directly the moment of inertia value was given. So the moment of inertia is nothing but mass into distance, the square of the distance. The distance is nothing but the bond length of the molecule, because the distance between the two molecules, the distance between the two atoms in a molecule is nothing but the bond length, and and due to this bond length, the two atoms are separated at a distance. So we will put the values of bond length in place of the distance, and we again know the value of reduced mass. So when there is a mass system, uh, so we need to find the reduced mass of the system in order to calculate their moment of inertia. So the reduced mass of the carbon monoxide molecule is also given, which is 1.14 into 10 to the power minus 26 kg. So if you put all the values, the again the energy states are also similar to the previous question. The lowest energy state, which is J equal to 1, and the ground state, which is J is equal to 0. So if you put all these values, you will get the answer. So these are the four options. I will give you a few minutes to try this question. Then after some time, I will solve those. Okay, so let's solve this question. The question says the bond length is given and the reduced mass of the molecule is also given. We need to find out the energy difference between the two levels. So similar to the previous question, we know the energy values are given by h square divided by 8 pi square I j into j plus 1. So the lowest rotational level is equals to j equals to 1 and ground rotational level is j equals to 0. So E0 is 0 and E1 is h square divided by 8 pi square I 1 into 2. 2 8 will cancel out. It will be h square divided by 4 pi square I. So here I is the moment of inertia, which is given by mu r square, and this mu is nothing but the reduced mass of carbon monoxide, and r is nothing but the bond length. So now see in the questions, the value of reduced mass of the carbon monoxide is given in terms of kg, and the bond length is given in terms of in the units of Armstrong. But the actual unit of distance is meter in SI units, so we will convert the bond length to meter. So since the value of reduced mass is given, it is 1.14 into 10 to the power minus 26 kg, and the value of bond length is 1.13 angstrom, which is 1.13 into 10 to the power minus 10 meters. So the moment of inertia I is nothing but mu r square, which is given as 1.14 into 10 to the power minus 26 into 1.13 into 10 to the power minus 10 square. So it is 1.14 into 1.13 square into 10 to the power minus 26 minus 20, it will be minus 46 kg into meter square. So if you calculate it, we can put these values directly to the expression of energy. So the difference in energy delta E will be E1 minus E0, that is nothing but h square divided by 4 pi square I minus 0, which is h square divided by 4 pi square I. So delta E will be 6.626 into 10 to the power minus 34 square divided by 4 into 3.142 square into the value of moment of inertia, which is 1.14 into 1.13 square into 10 to the power minus 46. So if you calculate, since all these units are in standard international standard units or SI units, so the value of energy will be in terms of joule. So it is 7.64. If you calculate, it will be giving 7.64 into 10 to the power minus 23 joule. So when you convert it to electron volt, it will be 7.64 into 10 to the power minus 23 divided by 1.6 into 10 to the power minus 19 electron volt, which is nothing but 4.77 into 10 to the power minus 4 electron volt. So this is the answer. And if you see the options, it was 4.77. So the correct option is option A, which is 4.77 into 10 to the power minus 4 electron volt. So this question is pretty much similar to the previous question, but in the previous question, the value of moment of inertia was direct given to us, so we directly put the value of I here, I in the previous question, but here the I was calculated and it was reduced mass into the bond length square. The bond length was given in Armstrong, so we converted it into meter by 10 to the power minus 10 by multiplying 10 with 10 to the power minus 10, and if you put all these values, so you will get the value of the difference in energy between the ground level, that is J equals 0, and the lowest rotational level, it is J equals to 1. So why we are calling the J equals to 1 as lowest rotational level? Because in order to have, in order to be considered as an energy level, it should be having some energy value, since the ground state energy is J corresponding to J equal to 0 is 0. So the fast or the lowest energy level is corresponding to J equal to 1, which is E1 level. So if you calculate, the energy difference will be 4.77 into 10 to the minus 4 electron volt, and the correct option will be option A. Then the next question. The question says the transition from J equals to 0 to J equals to 1 occurs in HCl molecule at frequency 6.3 into 10 to the power 11 cycles per second, where J is the rotational quantum number. Calculate the internuclear distance of HCl molecule. Given the value of H is 6.63 into 10 to the power minus 34 joule into second, and the value of Boltzmann's sorry, the value of Avogadro's number is given, which is 6.023 into 10 to the power 23 per mole. So per mole means 1 mole contains 6.03 into 10 to the power 6.023 into 10 to the power 23 molecules. So we will, so the options are 1.13 Armstrong, because we need to find the internuclear distance. Option B is 1.29 Armstrong. Option C is 1.49 Armstrong, and option D is 1.79 Armstrong. So I will give you a few minutes to try this question, then I will solve it. So let's solve this question. So here the same type of scenarios is also present. The transition is occurring from j equal to 0 to j equal to 1. But here in the place of energy, here we are given with the value of frequency, which is 6.3 into 10 to the power 11 cycles per second. And we need to find out the internuclear distance of HCl molecule, which is nothing but the bond length. But you must be wondering why the value of Avogadro's number, that is 6.023 10 to the power 23 per mole, is given. You can see in the previous two questions, in one case, the value of moment of inertia was given, and in other case, if you see here in the previous question, the reduced mass of carbon monoxide was given. But here, since the reduced mass of carbon monoxide and also the moment of inertia is not given, so we need to find out the moment of inertia in order to find out the moment of inertia, because definitely we will be needing the value of moment of inertia in order to calculate the rotational energy levels. So in order to find out the mass of the reduced mass of the hydrogen chloride molecule, we will be taking the help of the Avogadro's number, because we know in HCl the weight of H is 1 gram per mole and the weight of chlorine is 35.5, or we can take it 35 gram per mole. So for one atom, we need to divide the weight by 6.023, which will give us the value of the one molecule of the HCl molecule, the mass of one HCl molecule. So first, similar to the previous two questions, we know the value of rotational level is given by h cross square by 2I j into j plus 1, and this can be again represented in terms of rotational constant, which is called as B, as 2bc j plus 1. Now this expression 2bc into j plus 1 corresponds to the transition from j to j plus 1 or j plus 1 to j. So since here j equals to 0, j plus 1 equals to 1, the transition from 0 to 1, the energy is nothing but h nu. So simply we can write it as nu equals to, so 1 minute. So B comes into picture. B is the unit of B is nothing but centimeter inverse, which is a rotational constant. And when the C is multiplied, then the unit will be converted into frequency. Since in the question the frequency of the HCl molecule is given, we will write the expression in terms of B, which will be in the unit of frequency. So the transition corresponds to a frequency. The transition occurs from J to J plus 1, and this is 2bc j plus 1. So since j equals to 0, j plus 1 will be 1, and the frequency will be 2bc. And this frequency is given in the question, and the value is 6.3 into 10 to the power 11 cycles per second. Now, If we calculate the value of rotational constant, then from that we can calculate the moment of inertia, and from that moment of inertia we will calculate the value of the internuclear distance. So the value of B we know. The expression of B is given by h divided by 8 pi square IC, which will give us in turn I equals to h by 8 pi square BC. So putting the values, I will be 6.63 into 10 to the power minus 34 divided by 8 pi square into 1050, which is the value of B, because we know here 2BC is 6.3 into 10 to the power minus 10 to the power 11 cycles per second. So from here we can calculate B is to be 6.3 into 10 to the power 11 divided by 2C, which will give us 1050 meter inverse. So this is 1050 into C. C is 3 into 10 to the power 8. So if you calculate it, it will give you 2.67 into 10 to the power minus 47, and then it will be kg into meter square. So this is the value of moment of inertia. And again, the moment of inertia is given by I is equals to mu r square, where mu is the reduced mass, and this reduced mass is calculated mass of hydrogen into mass of chlorine divided by mass of hydrogen plus mass of chlorine. So since all these masses are in terms of the mass of 1 mu, we know 1 gram is mass of 1 mu of the mass of 1 mole of hydrogen is 1 mu. So we will divide the weight by the Avogadro's number to give which will give us the mass of one molecule. So 1 into 35 divided by 1 plus 35 into 1 by Avogadro's number, which is 6.023 into 10 to the power 23. So if you calculate it, it will give us 1.614 into 10 to the power minus 27 kg. So the reduced mass is also calculated. Now we know I equals to mu r square, which will give r equals to I by mu root over 2.67 into 10 to the power minus 47 divided by the value of reduced mass, which is 1.614 into 10 to the power minus 27 root over. It will give us 1.28 into 10 to the power minus 10 meter, nothing but 1.28 Armstrong. So this is the correct answer. And if you see the options, the closest option is 1.29 Armstrong. So the correct option will be option B. So in this question, the question was to find the internuclear distance of HCl, that is basically the bond length, and the frequency of the rotational frequency is given. So since we know about the rotational energy, the rotational frequency can be calculated, and in terms of frequency unit, we know the frequency of transition is given by 2BC into J into J plus 1. So since here J is equals to 0, so sorry, there is no J plus 1. Sorry, there is no J, only J plus 1, because if J is equal to 0, then frequency will be 0. So the transition between the two levels is direct proportional to the value of the higher J level. So since J equals 0, J plus 1 is again 1. So nu is 6.3 into 10 to the power 11, which will be equal to 2 BC. So from that, B can be calculated. B will be nu by 2C, which is 1050 meter inverse. And since the value of B is known, the value of B is nothing but H by 8 pi square IC. So I will be H by 8 pi square BC. So if putting the value of B, H, we calculate the value of I, and again the value of moment of inertia is mu r square. And in order to calculate the reduced mass of the HCl molecule, we need to find the mass of one single molecule. But when we are talking about the mass of HCl molecule, which is 36 gram, this is the mass of 1 mole of HCl molecule, which contains 6.023 to the power 23 number of HCl molecules. So for one molecule, the reduced mass will be divided in the expression of for calculation of reduced mass, we will divide the rotation, the Avogadro's number, which is 6.023 20 by 23. So by dividing, we will get the value of reduced mass is 1.614 into 10 to the power minus 27 kg. So if you put the values in the expression, it will be R equals to I by mu root over. If you put these values, the correct option will be this is 1.286, or the nearest correct option will be 1.29. So the correct option is option B, 1.29 Amsterdam. Now coming to question number 4. The question says, how many revolutions per second does a carbon monoxide molecule make when rotational quantum number J equals to 10? Internuclear separation of CO molecule is 1.13 angstrom. And similarly, the value of H and Na is given. So since you can easily solve this question, because we have been solving this type of questions today only. So here similarly the value of H and value of Avogadro's number is given. So we need to first calculate the value of reduced mass of the carbon monoxide molecule. Then from that reduced mass, we putting the values of internuclear separation, we will calculate the moment of inertia. And from using the moment of inertia, we will calculate the rotational energy. And from that rotational energy, we will calculate the rotational frequency, that is revolutions per second. So this question is pretty much similar to the previous question, but here we need to calculate their rotational frequency was given, but here we need to calculate the rotational frequency. The options are 1.64 into 10 to the power 11, 1.21 into 10 to the power 12, 1.79 times 10 to the power 13, 2.23 times 10 to the power 14. So these are the 4 options. I will give you a few minutes to try this question, then I will solve it. So let's solve this question. So in this question, the value of J is given. J is 10. So J is 10. So from this J value, we know the value of rotational energy is given by h square by 2I J into J plus 1. It will be for J equal to 10. E10 will be h square by 2I 10 into 11. So it is 10 into 11 is 110 divided by 2 is 55. So it is 55 h square by 2I. And you know to find the revolution that is new, we know E is equals to h nu. So nu will be E by h. It will be 55 h square divided by 2I h. So nu will be 55 h. This is 2. So there will be no 2I. It will be only, since we have, there will be only IH. It will be 4 pi square I. Now we need to calculate the value of I, and to calculate the value of I, we know I is moment of inertia, which is nothing but mu r square, and that mu r square is, mu is the reduced mass, and the reduced mass is for carbon monoxide. Carbon is 12, oxygen is 16, so it will be 12 into 16 divided by 12 plus 16 into 1 by 6.023 into 10 to the power minus 23. Then its value, if you calculate, will be 1.14 into 10 to the power minus 23 gram, which when converted into kg, it will be 1.14 into 10 to the power minus 26 kg. And R is also given in the question, I think. Yes, R is given. It is 1.13 Armstrong. 1.13 Armstrong, which is 1.13 into 10 to the power minus 10 meter. So I became 1.14, which is mu 10 to the power minus 26 into 1.13 into 10 to the power minus 10 square, 1.45 into 10 to the power minus 46 kg into meter square. So sorry, here it will not be J into, so energy is J h square J by 2I J into J plus 1. So the mu will be 6.63 into 10 to the power minus 34 divided by 4 pi square into 1.45 into 10 to the power minus 46 into 55, which will give us 1.21 into 10 to the power 12 cycles per second. So the correct option is option B, 1.21 10 to the power 12 cycles per second. Then coming to the next question, the question says, in the far infrared spectrum of HCl molecule, the fast line falls at 20.88 centimeter inverse. Calculate the bond length of HCl molecule given H is 6.60 into 10 to the power minus 34 joule into second, and Avogadro's number is also given 6.02 10 to the power 23 per mole. The options are option A 1.18 Armstrong, 1.29 Armstrong, 2.39 Armstrong, and 3.59 Armstrong. So these are the four options, and we need to find out what will be the bond length. I'll give you a few minutes to try this question. This question is pretty much similar to the previous question, but here we need to first identify what the value 20.88 centimeter inverse represents. So if once you know that value, then from that value we can derive the unknown value, that is bond length. So I'll give you a few minutes to try this question, then we will discuss. So now the first line falls at 20.88 centimeter inverse. It is given in the question. Now, if you remember, The first line corresponds to the transition from j equals to 0 to j equals to 1 or j equal to 1 to j equal to 0. And if you see the previous question, here, this was 2BC. So here this 20.88, now 2BC means it will be in terms of frequency, but here since it is given in centimeter inverse, so here this 20.88 centimeter inverse is nothing but 2B, which so from that we can easily calculate B. B will be 20.88 divided by 2, that is 10.44 centimeter inverse. Then we know the value of B is h by 8 pi square IC. Then I will be h by 8 pi square BC. So if you put the values, I will be 6.63 into 10 to the power minus 34, 8 pi square. B is 10.44. So you see 10.44 is 10.44 is centimeter inverse. So we need to convert it to meter inverse. So for meter inverse, it will be into 10 to the minus 2 into C. C is 3 into 10 to the power 8 meter per second. If you calculate, it will give you 2.68 into 10 to the power minus 47 kg into meter square. And again, mu will be, the molecule is HCl. We are already calculated the reduced mass. It will be 1 into 35 divided by 1 plus 35 into 1 by 6.023 into 10 to the power 23, 1.614 into 10 to the power minus 27 kg. So the value of mu is given. The internuclear separation will be R equals to I by mu square root. So it will be I is 2.68 into 10 to the power minus 47 divided by 1.614 into 10 to the power minus 27 square root, which is 1.288 into 10 to the power minus 10 meter. So this is 1.29 Armstrong. So the correct option is option B, 1.29 Armstrong. Now, so all these questions we are solving are pretty much similar. So if you practice, you can easily solve if it is coming in the exam. Now the question says, the far infrared spectrum of HF molecule consists of lines having a nearly constant separation of 40.6 centimeter inverse. Calculate the moment of inertia of the molecule given H is equals to 6.63 10 to the minus 34 joule in second. Options are option A, 1.378 into 10 to the power minus 47, 2.138 into 10 to the power minus 46, 3.719 into 10 to the power minus 45, and 4.232 into 10 to the power minus 47. Now, this is pretty much similar. We need to again identify what the value 4.6 signifies. So from this 40.6 centimeter inverse, we can calculate the required value of moment of inertia of the molecule. And here the molecule is HF, H1, and fluorine, the mass of fluorine is 19. So we need to consider these things into consideration so that we can calculate the moment of inertia of the molecule. I'll give you a few minutes to try this question, then I will discuss. So now solving the question. Again, if you see the higher infrared spectrum of HF molecule, concept line having a nearly constant separation, and the separation is 40.6 centimeter inverse, and and we know this 40.6 centimeter inverse nothing but the value of 2b. So 2b is 40.6 centimeter inverse. B is 20.3 centimeter inverse, or 20.3 10 to the power minus 2 meter inverse. Now we know B is equals to h by 8 pi square IC. Then I will be h by 8 pi square BC. H we know 6.63 into 10 to the power minus 23. 8 into 3.142 into so sorry, it is not 10 to the power, it is 10 to the power plus 2 not minus 2. It is 2030 into 3 into 10 to the power 8. So if you calculate, it will be 1.378 into 10 to the power minus 47 kg into meter square. So this is the expression for the moment of inertia of the molecule. This question is pretty much straightforward. The separation of 40.6 centimeter was nothing but the value of 2b. So from that value we can calculate the value of b. So when you once calculate the value of b, the expression is pretty much straight. So b is h by 8 pi square IC. So I will be h by 8 pi square BC. So if you put all these values, you can easily calculate the value of moment of inertia is 1.378 into 10 to the power minus 47 kg into meter square. I hope this is clear to you. Then the second question. The question says, the FgCl molecule emits a photon of wavelength 4.5 centimeter when it undergoes a transition from J equal to 1 to J equal to 0, where J is rotational quantum number. Find the internuclear distance in this molecule. The mass of Hg and Cl are respectively 6.32 into 10 to the minus 25 kg and 5.81 into 10 to the minus 26 kg. Given H is 6.63 into 10 to the minus 34 joule into second, and the options are 2.26 Armstrong, 3.27 Armstrong, 4.29 Armstrong, and 5.51 Armstrong. Now, if you see the question, the mass of Hg and Cl are given, and these are in 10 to the minus 25 kg. The units are 10 to the minus 23. Sorry, the masses are 3.32 10 to the minus 25 kg and 5.81 into 10 to the minus 26 kg. So here, if you see, the mass of one atom of Hg and Cl are given. So we don't need to consider the Avogadro's number or the molar weight. So here we will simply calculate the value of reduced mass by simply putting those values of the mass that are already given to us. So using those values, we will calculate the internuclear distance that we have been doing all the in today's interaction. More or less, we have solved all these type of problems. So I'll give you a few minutes to try this question, then I will discuss. So if we solve this question, the question is the molecule emits a photon equivalent 4.5 centimeter inverse, and that photon is corresponding to the transition from j equal to 1 to j equal to 0. Now we know from the first two questions that we have discussed today, the energy difference between first level and the lowest level and the ground level is given by delta E, which is E1 minus E0. Now E1 is h cross square by 2I j into j plus 1, which is h cross square by 2I into 2, that is h cross square by I. So E0 is again 0. So delta E is E1 minus E0, which is equals to h cross square by I, that is h square divided by 8 pi square I. Now this is h, this E is nothing but hc by lambda, which is h square divided by 8 pi square I. Then lambda is c by h square, hc by h square into 8 pi square I. So lambda will be c by c8 pi square I by h. So I will be h lambda divided by, sorry, one minute, we have so here it will be not, here it won't be 8 pi square because the 2 gets cancelled out here, the 2 gets cancelled out here, so it will be 4 pi square only, so it will be 4. Four pi square, 4 pi square, it will be h lambda divided by 4 pi square c. If you put the values, I will be 6.63 into 10 to the power minus 34 into 4.5 into 10 to the power minus 2 divided by 4 pi square into 3 into 10 to the power 8, which gives 2.52 into 10 to the power minus 45 kg meter square. So this is the correct answer, 2.52 into 10 to the power minus 45. Sorry, 1 minute. Here the we need to find the intermolecular distance. So this is the moment of inertia, and from that moment of inertia we will find the intermolecular separation and the reduced mass. From that we for that we need reduced mass value. So the reduced mass is given by mu equals to, since all the masses are given, so we need to simplify m1 m2 divided by m1 plus m2. So it is 3.32 into 10 to the power minus 25 into 5.81 into 10 to the power minus 26 divided by 3.32 into 10 to the power minus 25 plus 5.81 into 10 to the power minus 26. So this value is 4.945 into 10 to the power minus 26 kg. So R will be I by mu square root will be 2.52 into 10 to the power minus 45 divided by 4.945 into 10 to the power minus 26 square root. It will be 2.26 into 10 to the power minus 10 meters. That is nothing but 2.26 angstrom. So the correct option will be option A, 2.26 angstrom. So this 2.26 angstrom is the value of internuclear distance of HgCl molecule with all the given information that we have with this question. Now, question number 8. The question says the moment of inertia of H2 molecule is 5 into 10 to the power minus 48 kg meter square. Compute the temperature at which the average translational kinetic energy of H2 molecule equal to the energy difference between the ground rotational state J equal to 0 and the lowest rotational state J equal to 1 of this molecule. The value of H is given 6.63 into 10 to the minus 34 joule into second, and the Boltzmann's constant is also given because we need to find the translational kinetic energy. So why the value of K will, where the value of K will be used, I will be discussing in the upcoming time. The value of constant K is 1.38 into 10 to the minus 23 joule per Kelvin. Now the options are option A 105.7 Kelvin, 107.6 Kelvin, 119.6 Kelvin, and 129.7 Kelvin. So these are the four options. I will give you a few minutes to try this question, then I will discuss. So here, if we see the question says the moment of inertia of hydrogen molecule is 5 × 10⁻48 kg into meter square, and we need to find out the temperature at which the average translational kinetic energy of hydrogen molecule will be equal to the energy difference between the ground state and the lowest rotational state. So in the previous questions, we have calculated the energy difference, but we need to calculate here the temperature at which this energy difference will be equal to the translational kinetic energy. Now let's first calculate the energy difference between these two levels. So we know EJ is h square by 8 pi square I j into j plus 1. Then for j equals to 1, E1 will be 2h cross square divided by 2I. It will be h square divided by 4 pi square I. And for j equal to 0, E0 is 0. So delta E, that is E1 minus E0, will give us 2h square divided by 8 pi square I, which is h square divided by 4 pi square I. Now this energy, according to the question, is equal to the average translational kinetic energy of H2 molecule. Now, considering the law of equipartition of energy, we know since the molecule is in 3 dimensions, it has 3 degrees of freedom. So for each degrees of freedom, the energy per degrees of freedom for molecule is half kT. So for 3 degrees of freedom, it will be 3 by 2 kT. So this energy delta E is equal to translational kinetic energy, which is equal to 3 by 2 kT. Now, this is h square divided by 4 pi square I equals to 3 by 2 kT. That implies P equals to h square divided by 6 pi square I into kb. So since the all values are given, k is also known, 1.38 into the minus 23. So if you put this 6.63 into 10 to the power minus 34 square, 6 into 3.142 square into the moment of inertia of hydrogen molecule is again given 5 into 10 to the power minus 48 into k 1.38 into 10 to the power minus 23. So if you calculate it, the temperature will be 107.6 Kelvin. So this is the correct answer, 107.6 Kelvin. So option B is the correct option. So this question was a bit tricky because in this question it was given that the difference in the energy between two energy levels is equal to the translational kinetic energy, and the translational kinetic energy we know according to the law of equipartition of energy is degrees of freedom gives the energy half kT. So here considering the 3-dimensional, the average kinetic energy is 3 by 2 kT. So this 3 by 2 kT is equal to the difference of energy between the ground rotational state and lowest rotational state. So if you equate these two energy, delta E will be equal to 3 by 2 kT. And if you put all the values that are known to us, the only unknown is the temperature, and that temperature is 107.6 Kelvin. I hope this is clear to you. Then the ninth question. The question says, Now this question is based on the vibrational spectra. Assume that hydrogen molecule has a force constant of K equals to 535 Newton per meter. What is the vibrational quantum number corresponding to the dissociation energy of 4.5 electron volt for S2 molecule? Consider the reduced mass of S2 is Np by 2, that is Np is the mass of proton. The mass of proton is also given 1.67 minus 27 kg and the Planck's constant 6.626 into 10 to the minus 34 joule into second. The options are option A 6, option B 8, option C 12 and option D 14. I'll give you a few minutes to try this question and after that we will discuss. Basically in this question the force constant is given and we need to find out what is the vibration quantum number, that is small v, which will correspond to the diffusion energy of 4.5 electron volt for hydrogen molecule. And we have to consider the mass of hydrogen molecule. The reduced mass of hydrogen molecule is Mp by 2. This Mp is the mass of proton, which is 1 mu or 1.67 10 to the minus 27 kg, and the Planck's constant is also given. So I'll give you a few minutes to try this, then we will discuss. So let's solve this question. Now, in this question, the force constant K is given, and we know, talking about the vibrational energy levels, because here the dissociation energy nothing but the vibrational energy, and the vibrational energy is 4.5 electron volt, and the expression for a simple harmonic oscillator we will use the expression. The vibration energy EV is h cross omega n plus half. And this value of n we need to calculate. And this is the vibrational quantum number. Vibrational quantum number. Now, this value is equal to 4.5 electron volt. So, h cross omega into n plus half equals to 4.5 electron volt, or 4.5 into 1.6 into 10 to the power minus 19 joule. Now, uh, we don't know the value of omega. So here we need to find out the value of omega. Now the value of omega, if you recall the concepts, the value of omega is given by k by m root over. So omega is nothing but k by m root over. But since here it is a molecule and it has two hydrogen atoms, so the reduced mass will be taken into consideration, and the reduced mass will be mu. So here it will be k by mu root over. So we know the value of k, which is given in the question. K is 575 divided by the reduced mass. Reduced mass is mp by 2. It is 1.67 into 10 to the power minus 27 by 2. So it will be into 2 here. So this will be the value of omega. So h cross omega into n plus half is 4.5 into 1.6 into 10 to the power minus 19 coulomb, so 19 joule. So n plus half will be 4.5 into 10 to the power minus 19 into 1.6 divided by h cross is h by 2 pi, 6.626 into 10 to the power minus 34 divided by 2 into 3.142 into the value of omega, which is root over of 575 into 2 divided by 1.67 into 10 to the power minus 27. So if you calculate it, the value of n plus half will be 8.529. So n will be 8.529 minus half, which is around 8.029. So since this quantum number is an integer or the natural number, so it will be 8. So this is corresponding to n equal to 8. So the for hydrogen molecule, the quantum number, the vibration quantum number n equal to 8 will correspond to the dissociation energy of 4.5 electron volt with a spring constant or the force constant of 535 Newton per meter. So since the expression for vibration energy contains h cross omega into n plus half. So n is unknown, h cross we know, omega we need to calculate. For omega, the value of k and mu is given, and the relationship between k, mu, and omega is equals to square root of k by mu. So we put the values of k and mu here. So this is nothing. So this is not 75. This is 535. So it is 535. So if you put all these values, the only unknown is n. So n plus half will be 8.529. So 8.5 minus 0.5 is 8. So the value of vibration quantum number is 8. So this is the correct answer, and the option D will be the correct option. Now question 10. Given spacing between the vibrational level of a carbon monoxide molecule is 8.45 into 10 to the power minus 2 electron volt. Calculate the value of force constant of the bond in a carbon monoxide molecule. Consider the reduced mass of carbon monoxide is 192 by 28 into mass of proton, and the mass of proton is given and the Planck's constant is given. The options are 181 Newton per meter, 191 Newton per meter, 211 Newton per meter, and 231 Newton per meter. So these are the four options. I'll give you a few minutes to try this question, then I will discuss. So now the question is pretty much similar to the previous question, but the difference is in the previous question the force constant was given and we need to calculate the quantum number, but here the force constant is need to be calculated. The spacing between the vibration level is given, and if you remember the spacing between the vibrational level, if you see here, E was h nu or h cross omega n plus half. So n equals to 0, 1, 2 like this. So for n equal to 0, it is h cross omega by 2. N equal to 1, 3 h cross omega by 2. N equal to 2, 5 h cross omega by 2. Like this. So the separation or the difference in energy between the two levels is always h cross omega, whether it is 3 by 2 minus half or 5 by 2 minus 3 by 2. So since it is varying linearly, so the difference between the two levels is always the same, and that difference is given to be 8.45 into 10 to the power minus 2 kiloton volt. So this energy is nothing but h cross omega h nu. So h cross omega or h nu or the energy difference is 8.45 into 10 to the power minus 2 kiloton volt needs to be converted into joule, which is 1.6 into 10 to the power minus 19. So this is joule. Now the frequency, because in order to calculate the value of force constant, we need to calculate. So in order to find the value of force constant, in order to find the value of force constant, we need to know the value of omega and value of mu, because these three are interrelated. So we will calculate the value of omega. So omega is nothing but 2 pi nu. So nu is delta E by H, which is 8.45 into 10 to the power minus 2 into 1.6 into 10 to the power minus 19 divided by 6.62 into 10 to the power minus 20, sorry, 10 into minus 34. So now this is mu, and if you calculate it or solve it, it will be 2 into 10 to the power 13 per second. Now the omega is given by k by mu root over. So k is omega square mu, and the value of k will be given by omega square into mu. Omega square is 4 pi square into nu square, because omega is equals to 2 pi nu into the reduced mass. The reduced mass is also given 192 by 28 into mass of proton. So it will be 4 into 3.142 square into nu is 2 into 10 to the power 13, 2 into 10 to the power 13 square into mu is 192 divided by 28, 192 divided by 28 into mass of proton 1.67 into 10 to the power minus 27. So if you calculate all these, it will give us simply 180.8, 180.8 Newton per meter, or it will be 181 Newton per meter. So it is matching with the option A. So the correct option will be option A. So in this question, it was given that the spacing of the spacing between the vibration and level was given, the reduced mass was given, and we need to find out the value of force constant. And in order to find out the value of force constant, we need to know the values of reduced mass and the angular frequency of vibration. So since the reduced mass is also given, we only need to find out the angular frequency of vibration, and the angular frequency of vibration can be calculated from the energy spacing between the vibration levels, because the energy spacing is nothing but the h cross omega or h nu. So if you put these values and calculate, you'll reach at a time, you'll reach at a point where the value of nu will be given to us, the value of mu will be known to us, and the value of mu is also given to us. So when you calculate the value of k, you can easily calculate k will be omega square mu, and this k, if you put the values, k is 181 Newton per meter. So these are the questions that I had to discuss in today's interaction session. In the next interaction session, we will discuss a few more problems, which will be based on the week 11 lectures, which will be our 11th interaction session. So till then, I wish you good luck for your exams. That's it for my side.